Hello students, welcome to my lecture. In this video, I will discuss a important question from the modern physics and the topic is Rutherford alpha particle scattering experiment. Let's see the question. Square root of d1 and d2 are the impact parameters corresponding to scattering angles 60 degrees and 90 degrees respectively when an alpha particle is approaching a gold nucleus. Then what is the relation between d1 and d2? Okay, so let us see little bit elaborately what is the problem they are asking. In gold foil experiment, the gold atom will be here, the nucleus will be here, assuming which is at rest. Obviously this is at rest as heavier one. The lighter projectiles, generally alpha particles, are coming in this direction. So let's say the alpha particle which is coming in this direction, I am taking whose charge will be Z2 multiplied by E, and of course it is coming with a velocity V0 and whose mass is M, and it's supposed to go in this direction. So this distance generally I call as the impact parameter. But we know that because of Coulomb repulsion, the particle will not go like that. The particle will be going like this. So it is reaching the nearest position here. This is the nearest position it is reaching here. I call it the minimum separation. Then going like this. So that means if I draw a tangent to this trajectory, finally how it is going, which makes an angle theta with the initial direction. So this is the initial direction and this is the final direction. So this is the angle theta. We can call it the incident direction. We can call it the scattered direction. This theta will be the scattering angle and this B will be the impact parameter. Here B will be the impact parameter. Scattering angle will be theta. And of course this is the minimum separation between the projectile, that is alpha particle, and the nucleus. So as the nucleus is heavier one, we can think of the nucleus is at rest. And this instant it makes an angle 90 here. So then how we will solve this problem? There are few ideas. For example, I can approach the conservation of angular momentum with respect to nucleus. Conservation of angular momentum. So this idea. And what is the other idea will be conservation of mechanical energy. With the help of these two ideas, I can get a relationship between impact parameter, scattering angle, minimum separation, and all those things. Okay, thus details I will not go here. I will give the results for impact parameter and scattering angle. So the impact parameter and scattering angle are related something like this. So B will be is equal to, so Z1E Z2E divided by 4 pi epsilon naught into mv0 square into cot of theta by 2. Cot of theta by 2. So this formula is sufficient to solve this problem. And similarly I will give for the minimum separation between the nucleus and that projectile, that is alpha particle, is given by B cos of theta by 2, cos of theta by 2 divided by 1 minus sin of theta by 2. So for a special case when B is equal to 0, in that case that R minimum will become, that is, this is the case, limit theta tends to 180 degrees. So that time it will be Z1E into Z2E divided by 4 pi epsilon naught into mv square. So that is half mv square. Something like loss in kinetic energy will be is equal to gain in the electrostatic potential energy ideas. Okay. So at present I required this formula to solve the problem. So remember these formulas. Okay, so that means in one line answer I can say here B is directly proportional to cot of theta by 2. B is directly proportional to cot of theta by 2 here. Okay, so in the first case it is root d1 and root d2 are the impact parameters when the angles are 60 degrees and 90 degrees. That is root d1 divided by root d2 will be is of cot of theta 1 by 2 divided by cot of theta 2 by 2. So theta 1 and theta 60 and 90. D1 and D2 60. Cot of 60 degrees by 2. Cot of 90 degrees by 2. So square root of D1 by square root of D2. Cot of 60 means cot 30 degrees here divided by cot of 45 degrees. Of course cot 45 degrees is 1. Cot root 3 divided by 1. So that means D1 will be is equal to 3 times of D2. Okay, that's it. So you remember these formulas. They can ask any type of problems. We can solve these type of problems with the help of these ideas: conservation of angular momentum, conservation of mechanical energy. The results I am writing here, these are the results, final results I am writing here. Just remember, this is enough. Okay, I hope it is clear. So thank you for watching my video. Please subscribe my channel and don't forget to like and share.